So hey guys, today we are going to discuss about Gaussian integral. Which is basically minus infinity to infinity a raised to minus x square dx. So we need to find this integral. Let it be I. And here I am considering xy coordinate system. So if this is true for x, then this must be true for y as well. Let us take this as equation number 1 and let us take this as number 2. I'm just multiplying these two, and this will give I into I, which is equal to integral from minus infinity to infinity e raised to minus x square plus y square dx dy. Now let's change the coordinates. I have to shift from Cartesian to polar. R and theta, x and y. So how can we do that? Okay, so you have to take in such a way that x is equal to r cos theta and y is equal to r sin theta. Basically, in this coordinate system, a point is represented like this, where this is r and this is theta. If you square and add, you'll get x square plus y square is equal to r square. And in this coordinate system, a small area is represented by dr into r d theta, where dr is this small element and r d theta is this element, where this is the d theta and this length is dr. So you'll basically get something like this: d theta r and this length, this is r d theta. You have to multiply this with dr, so you'll get this area. But whereas in Cartesian coordinate system, the same area is given by dx into dy. You can see here that this is dA, let this be dA. So in the polar coordinate system, that dA will be dr into r d theta, but in the Cartesian system, that same dA will be dx dy. So I'm just changing the coordinates. So the integral becomes I square equals so the limits will also change. I'll talk about that. So here you can see that it was e raised to minus r square. You can see that from here, you can see, and that was dA, so that will be r dr d theta. Now you can see that in this polar coordinate system, r varies from 0 to infinity and theta varies from 0 to 2 pi. So I'm exactly writing that here. So r from 0 to infinity and theta from 0 to 2 pi. And you can see that d theta is a separate quantity here, so we can just do the integration separately of these two. Basically, this will become r e raised to minus r square dr and d theta. So it's this from 0 to infinity, and this is from 0 to 2 pi. Now this integration will give you 2 pi. And what about this? So here just take r square as some t, so that 2r dr will be dt. You can see that the limits will be the same, because as r is 0, t will be 0, and as r is infinity, t will be infinity. The only difference is that t will go to infinity faster than r, but the limits will be the same. So here I square will become 0 to infinity. So 2r dr was dt, so r dr will be dt by 2. And this will be e raised to minus t into 2 pi. You can cancel these two 2's. And you can see that the integral becomes, you can see that the integral becomes pi into e raised to minus t dt from 0 to infinity. So here this is I square, which is, so integration of e raised to minus t is minus e raised to minus t from 0 to infinity. And if you apply the limits, you will get this part as 1. This will be pi. But this is I square, so we need to find I, which will be the square root of this. And mind that this I is nothing but minus infinity to infinity e raised to minus x square dx. So this is nothing but the Gaussian integral. And you should not be confused with the, so you should not be confused with the limits here. The limits are from minus infinity to infinity. Okay. So you can see that this is a symmetric graph, because you see, if you consider this as f of x, where f of x is equal to minus a raised to x square, in this plot this here. Yeah, I'm just taking this as y. So this graph will somewhat look like this. At x equal to 0, y will be 1, and as x tends to infinity, or as x tends to minus infinity, y will go to 0, y will be tending to 0. So this is an even graph. And so we can say that if you consider I1, which is from 0 to infinity, e raised to minus x square dx, this will be half of the integral which we have just found, which is root pi by 2. And this will be the same for minus infinity to 0 e raised to minus x square dx, which will also be the same. Now, if you want to find out the integral of, say, this one, then what will you do? Let us take this as some I2. So we can say that, okay, so in this case, it's easy. Just take root of a x as some t, where ax square is, yeah, so how do we solve this? So in this case, we can take yeah, so we can take root a into x as some t, so that ax square will become t square and dx will become dt by root a. So this I2 integral will be minus infinity to infinity a raised to what is this? Yeah, minus t square. In place of dx, it will be dt by root a. So okay. So what about the limits? The limits will be the same, right? Because here, if you put minus infinity, you'll get minus infinity as t square, and for infinity as well, t will be infinity. Yeah. So it will only the limits will not change, but maybe the rate of the function on reaching the infinity or minus infinity might be different. Maybe it may be slower or faster depending on the value of a. But other than that, the limits will not change. So we now know this integral, which we found out earlier, which was root pi. So this will be 1 by root a into root pi. Now, yeah, so this will be root pi by a. Now, just take another integral, say some I3, suppose, from minus infinity to infinity, a raised to minus ax square plus bx dx. To find this integral, what we have to do is we have to complete the square. Complete the square. So basically, you can just take some y or some, say, some u to be minus ax square plus bx. Now, let's take this minus out, a out. So it will be x square minus b by a x. And this will be, so this is nothing but some x square minus 2ab kind of a term. I'm just doing like this, by x. So we need the square of this term here. So I'm just adding the square of this and subtracting the square. Now, if you see, this will be x minus b by 2a. That's right. Yeah. The square of this and minus b square by 4a. 4a square. And just take this thing out. You'll get, yeah, this a square is not there. So just multiply these things inside. You'll get square plus b square by 4a. So we found out this. Now we can just substitute back. Yeah, so we got this term now, which was this one. So from minus ax square plus bx, we got this term by completing the squares. Now we can just substitute this in the previous one, which was I3 is equal to integral minus infinity to infinity e raised to. So instead of this, we can just write this term, which is yes. Now we can just take this term out because e raised to b square by 4a is a constant. So this will become b square by 4a. This will be like this: a x minus b by 2a square dx from minus infinity to infinity. Now you can see here that this term, this overall term, is similar to e raised to, this overall integral is similar to this one, because it's just a constant inside. So, or if you have any difficulty, then let's take this whole thing to be some t. So this, let's take x minus b by 2a to be some t, or some, maybe you can take it as some p, such that dx will be dp, and the limits will be the same. As x tends to infinity, p will also tend to infinity, and the same for minus infinity as well. So let's do it. I3 now will become e raised to b square by 4a minus infinity to infinity e raised to minus a b square dp. Now we know this integral we had derived previously. So just write that. This will be e raised to b square by 4a, and this will be root pi by a, which is nothing but now this is important. Why I have discussed here is that if you are doing Fourier transforms, you will get some terms like some f of x into e raised to minus ikx, something like this, right? So the limits can be, if it is minus infinity to infinity, if you get some term like this, where f of x is e raised to minus x square, suppose, or some minus in the form of some minus ax square, then you can just directly apply this formula. Because if you see, if you try to complete the square and do it, since there is an I, it will be hard. I mean, we can do it. If you have time, you can do it, but it will be hard. It will be lengthy. So if you know this result, then it will be good. You can do it faster. So we have learned 3 results here. The first one being I. Okay, I'm not writing I. I'll just write the whole expression. So first one was minus infinity to infinity e raised to minus x square dx. This was equal to root pi. From here we have said that integral from 0 to infinity e raised to minus x square dx was root pi by 2, because this curve was symmetric with respect to y-axis. Now the second expression was this one, e raised to minus x square dx. This is equal to this one. Now the third and the final one, which we discussed today in this video, is this. So yeah, these are the 3 important results which you should have an idea. I mean, if you can solve this, then you can just derive these two easily. So, and all of these graphs will be the somewhat like the same. You can see that all these things, graphs will be somewhat like this only. Yeah, so if you are doing, these things will come in probability. So probability, quantum mechanics, mathematical physics, and all those things. And also in maybe Fourier transforms. So Fourier series, etc. There it will be very helpful, especially these things, these expressions. So that's all for today. Hope you liked it. I'll discuss some other types of integrals in my following videos, coming videos. So stay tuned.